Okay, today what we're going to do is we're going to use a matrix to set up a system of linear equations. So this is matrix setup. For a system of linear equations. Now remember that a system of linear equations is any type of equations that are first order. So if I have the equation 2x plus 1y equals 15.5, and I have the equation 2x plus 2y plus z equals 37, and I have the equation 4x plus 3y plus 2z equals 72.5. This is still a set of linear equations. It doesn't matter that these aren't lines, that they're planes. Every variable is a first order, which just means it's to the exponent of 1. So when we write x plus y equals 3, this just means x to the first power plus y to the first power equals 3. And so it's a linear equation because the variables are all to the first order. Okay? Now, to make a matrix it's not that big of a deal, but you have to understand what it is you're actually doing. It's like exploding these equations. If I rewrite this, and I'm going to write 2x, 1, y, and there's a plus, and plus 0 z's, because I want them all to have the same variables, and there's no z here, so I'll just do 0 of them, equals 15.5. 2x plus 2y plus 1z, because I have just 1z, equals 37. And 4x plus 3y plus 2z equals 72.5. Okay, now I have a constant number in front of each one of my variables. I have the same variables, they are stacked, so they're just like I would do elimination. I have stacked y's, stacked x's, stacked y's, and stacked z's. So now what I want to do is I want to create an equation where my x, y's, and z's are all together. So what I do is I create a matrix, and the matrix I'm going to call A. And I use a capital A. Capital A signifies that what I'm going to create is a matrix. Then I'm going to create an X, which is a vector. And the little line above the X here means it's a vector. And that will equal B, which is again a vector. Okay, so what I'm going to do is my matrix is my constants. Okay, so here it's going to be a 2, a 1, a 0, a 2, a 2, a 1, a 4, a 3, and a 2. So now these are my x's, these are my y's, these are my z's. I can see that. Now my vector x is just a stacked vector, it's a 1 by 3 vector of my variables. So I have x, y, and z. Those are my variables. It will equal to a stack of my solutions. Now I have my matrix, a vector, matrix times a vector time equals a solution. This will be called a dot product when I multiply them, and how you multiply them is such. I take the first element of my matrix times the first element of this vector. the second element of the matrix times the second element of my vector, the third element times the third element of my vector. Then I go down and my second equation is just this times this times this, plus this times this. Third is this times this, plus this times this, plus this times this. And so you can see how it forms. But that's how you make a vector and matrix for a solution for systems of equations.